of Technology Tirupati, and this is the 11th session for the deep learning course. So today we are mostly looking at something, a different kind of problems, which is called a sequence learning problem from whatever we have seen today earlier, and we are going to introduce RNN as a concept, as an architecture as of now. Okay, so from RNNs multiple other architectures are there, but today our aim is to just to motivate you that why you should use RNNs in your programs as a technique that you should learn, right? Like CNN is for images, why RNN is useful useful architecture for multiple tasks. Okay, so that is our that is something I'm trying to build as a motivation here. Okay, so the session will be divided into two parts. The first half, that is 1 hour, I will be talking mostly about the sequence learning problem and what is RNN. I will try to bring the intuition of RNN, followed by in 1 hour we will code a basic RNN model which we can use to see that how it works, okay, for the sequence learning problem. So let me start by sharing my screen. Just a minute. Okay, I think my screen is being shared right now, and okay, fine. So let's start with it. So to define sequence learning problem, we just let's look at what as a problem we have seen as of now, right? So what kind of network we have seen? We have seen mostly two type of networks towards the whole course, two network architectures with respect to deep learning. Okay, so first architecture is pretty straightforward that we have started off with. This is considered as a fully connected network. So this is how we started off with. So that means I have input x1, x2 till xn. Okay, so based on that I have some input. This is something called as input layer, and I have in between I have hidden layers, and at the end I have some output layer. Now this can be mostly we have seen from the perspective of classification, but regression, it all works fine from regression classification tasks both. So the property of this fully connected network is each neuron, so any number of neurons that you are defining in a hidden layer, input layer or output layer, that has been fully connected to each other, right? So there's no in between of that, okay, I will only choose one particular neuron. I'm connecting each x1 as an input to each of the neurons, three neurons at the hidden layer 1, right? So I'm connecting to them, and each of the hidden three layers of hidden neuron, three neurons, I'm connecting to the above the second hidden layer, right? So all the connections are there along with the biases. So this is one type of um, uh, fully connected network we have seen. Right now, the second network that we have seen is mostly with respect to the image, which can solve images. That is the convolutional neural network. So this is coming from the architecture that we have an image. Okay, we apply something called as convolution operation on top of it. Okay, so for that we have some convolution layers. So for this we have multiple convolution layers, and then we apply something called as max pooling on top of the convolution layers, and then we have a fully connected layer. So the pink one is fully connected layers. Okay, so it is a one step ahead of fully connected layer, where if I want to deal with a particular image, if I want to deal with multiple sets of images, I want to learn those images and divide them into a particular classification, multi-class classification, I can use a CNN model. Okay, now that being said, there's some common properties with respect to this. Okay, now what is the common properties is that when I'm taking the input, okay, the input is of fixed length. That means if I'm taking image, the image will be 28 cross 28 image. That is okay, like that, with maybe 3 scale RGB. The input that I am taking, like x1 as a x1 as a one row of input, or x2 as another row of input, like that. So I am taking same number of features. The each input instance will have same number of features. So right, x1 I might have 30 features. So I am passing all those 30 features into this fully connected layer. So similarly, the x2, the another instance of input, I will take the which also consist of 30 features, and I'm passing all these features to the fully connected neural network, right? So the instances are same, right? Similarly, if I'm passing an image, all the image dimensions will be same for all the images, right? It's not like one image will be 28 cross 28 and another will be 32 cross 32 cross 7. It's like that. So that doesn't work like this in convolutional network and fully connected network. So I have this, so all these, both the images are actually have a fixed set of inputs. Okay, so once I define an input size, that is something I'm going to follow for the whole data set. Okay, so that is one point. Second point, let's go to the output. Okay, so how model is training is it taking one input at a time, or maybe batches of input at a time. We're trying to train to a certain extent. Again, we'll take new batch where few set of inputs will be again new train, and all those stuff, all that thing process and training is going on, right? But the interesting fact is that my input, let's say right now it's apple here. Now if I bring banana into the picture, okay, this banana as an image doesn't have any effect on the apple, right? Apple as as a individually as one input, it's there. So banana doesn't have any dependency of the on the apple, right? So any input that I am giving right now, I don't have its relationship with this input previous input. So that is what we have seen, that we can see in the input case, right? Similarly, so when I'm generating an output, so if I'm saying, let's say I have a class in this CNN layer, I'm telling that this is an apple as a class. So that means I'm not doing an so when I'm maybe classifying banana as a one of the class, I'm not saying that it is dependent on the output of an apple, right? It is by default, it is training some weights, and based on that it is trying to classify that banana as a one class, right? So outputs are independent of previous inputs. Okay, so these are the main 2 points that we have been observed usually in a typical CNN network or a fully connected network. Okay, now all that is good. Now let's see, let's take a different case of example. I would like to see that whether we have certain problems which is actually opposite of these 2 points, that is input have as a variable length and output is actually dependent on previous input, right? Do we have such kind of problems? So let's take a now everyone have used this autocorrect in their keyboard, right? Autocorrect or autofilling in their keyboards which you use in mobiles, right? That you have seen. So for example, let's say you want to write a deep as a word, so you write D, okay, then it might suggest few words with respect to, but if you write E again, then it might suggest the words start with D and E, right? It will automatically suggest us, and based on that I might say that okay, I found the deep, and then I will select on the deep word and it will put down in my chat whatever message I am writing, right? This is what we have observed already during our when we text, right? But how do we put that in a context of a model, right? As a neural network model, can we create a certain model which can predict that if I have a D, now my output should become as E, right? And now if I have a E, now my another output as a since I'm predicting that what should be my next character, it should be E, because now I have to dependent on D also. I can't take E as a standalone input, because I know this is another character between before my input. So I need to take that into consideration to produce an output called E. Now if I take another E, so I have now 3 characters into the picture, that is D, E, E. Now I have to find the predictor 4th character. So in this case, by intuition or by our knowledge, we know that if we have 2 D double E, so most probably the last 4 word will be P, right? So since the way how we know, we want to train the same way to our neural network, right? So okay, so in this case what is happening, that I am giving D as an input. So this is my input layer, this is my blue is hidden layer, and this is my output layer, right? So D, let's say that I have something of, you might heard of one hot encoding, right? So that means I have 26 letters in a, or 26 alphabets in my English language. So I will say that I will assign D to 0 0. So wherever the D position comes in alphabets, that is at fourth position, I will keep as 1, and others I will keep as 0 0 0 till 26, right? So I am giving this as a vector, as a number, because obviously I have to deal everything in a in the terms of vector matrices, that too in numbers, right? So I give this as an input. Now this input is given here. Some computation has to happen in this blue layer, okay, that is hidden layer, and output, it has to give me one hot encoding kind of thing. It has to give certain probability that the next character for me, it should be E. That means the first four letters will be 0. At fifth position I should get 1, or at least I should get certain probabilities and give a probability that my E probability, that is fifth position in the alphabet, should have a higher probability. So I will take that as a probability that my next next letter should be E. Okay, so now what we can observe from here, that we have some input, we are applying what process, some processing, we don't know what kind of processing we are applying, and then we are getting certain output, right? In a similar, in a single, this is one single model, right? And this is, I'm using red pen now, red part, so I'm create box. Now this is another neural network, this is third neural network, this is fourth neural network, right? Now once I able to, maybe I'm able to say that okay, after D I should get a E, right? But how should I tell that from E, which I'm going to take as second input also, that that this E is actually dependent on this D, okay? And after these two characters DE also, I should get a third character, right? So how should I pass this data? Okay, so this problem where this problem where my output depend on previous input, okay, this is one thing, okay. So that is the one problem, that my output is dependent on previous input, because based on that only I can predict the next letter in this case. Now this is a four, so we have created four neural network, four simple neural network for 4 words, right? But what say, let's say I will create, I need a word of learning, right? Now it has how many words? It has 8 words, right? So shall I keep on making the 8 different neural architecture? It is not feasible for me, right? So what is, so I need certain architecture which takes care that the output depend on the previous input, okay? Then the length of the input is not fixed, right? I can, based, because we are dealing with a natural language, so a language can have a number of words with different ranges and sizes and all that, right? So so what is actually, now we can see that I have this problem where my output is dependent on previous input, and also my input is not as fixed, right? Because I'm using words, so the words can be variable of variable length, right? So this kind of problems we call as sequence learning problems. So what is sequence learning problem? That I am taking a certain input of variable length, okay, I'm generating some output out of that, but that output is actually dependent on my previous inputs as well. So this is called a sequence learning. So I have a sentence, let's say sentence is a sequence where each sentence has few words into it, and each word is somehow connected to another, right? So like if I'm saying I'm studying in IIT Tirupati, I have to, if I have to make this understandable, if I have to make this as understandable to the mind neural network, I have to pass all this part, that there is something called as I, something called as I'm something called as studying, into a neural network, and should connect to each other, right? This is not standalone input, and or if you, and you can also see that all this 5 words that I am using are of different input size, right? So this kind of problems are quite normal, and we will see that what different kind of problems, tasks that we can see in this sequence learning problem. So this is quite frequent amount of problem that we can see in our day-to-day life with respect to machine learning or deep learning challenges. Okay, so this is now if you're able to understand that, that sequence learning problem is something where my input length is not fixed and my output depends on my previous input, that is more than sufficient as of now. Okay, now that being said, so now I can safely convince you that input is a sequence you can say right now for our understanding is a set of sentences or words or characters. Okay, that is based on the task that we are having, and output is also a sequence. Now how it is a sequence, let's see a few examples. Based on that you can understand. So let's see this example. So it has input like, it was an awesome movie. So it is a sentence with 5 words, right? It was an awesome. So there's a problem called as part of speech tagging. Okay, so I have something called part of speech tagging, where I am saying that for each word I need to identify certain part of speech. Now what is part of speech? Basically a noun, verb, adjective, pronoun, punctuations and all those stuff, right? So my model task, I want to train my model in such a way that if I'm giving it, it should tell me that it is a pronoun. If it has was, it should tell verb. If it is an, it should be an article. Awesome means adjective, and noun is movie, right? Now, if so, if we know a little bit of from English grammar, we know that if there's a noun and before that if there's a word, there's a high chance that, or there's certain chance that it mostly a adjective with respect to the noun, right? So that is what we can think of. So we can train a model think that if there's a word as a noun, if you find a word which is a noun, before that there's a chance that with the word which is occurring before that might be an adjective. So I can change my output with respect to that, right? So this is a sequence. I have an input as a sequence of characters here, okay, or as a words. Now and my output, now you have to see that now movie is a noun. You can only say movie is a noun when you analyze both the earlier 4 words, that is it was an awesome. Okay, you can't just say movie as a noun without any context, right? You have to see it that in the whole sentence, right? So that is one thing. Another thing is, for each word I'm putting some output. Now output also, if you can see, it is the output of pronoun, verb, article, adjective, noun. It has multi-class, right? Either you can take it as a multi-class or you can generate it as a proper output sequence where pronoun is of 7 words, verb is of 4 words, articles of 6 words, kind of like that, and so on, right? So my output is a sequence, say input as a sequence, and output is also a sequence. Okay, now what we call as, we call this as sequence classification problem. Sequence classification problem. The part of speech tagging is one such example there, where we are defining a sequence, and for each part of the sequence we are defining an output sequence for that, right? So part of speech is, it is basically a pronoun like that. Okay, now there's another set of problem here, which we are saying that the movie was very boring, right? And we are just outputting at whether it's a positive comment or a negative comment, okay, or negative review, like that. Okay, if I just want to know this, I don't want that, I don't want to analyze each and every word in the sequence. What I want to do is, I just want to say that at my last after analyzing the whole sentence or whole sequence, I just want to tell me which it belongs to, whether it's a positive or negative, right? You can say it's as a sentiment analysis. Sentiment analysis of the text. You might heard of sentiment analysis earlier. So, so if I have a sequence, I'm giving this, and I just need to know is a positive, negative. So now this type of problem is called a sequence labeling problem. That means I have a sequence and I'm labeling that whole sequence to a certain label. Here it can be positive, negative, or maybe something else like that. Okay, so now we have seen 2 different type of sequences here, which we can use it. So which is further divided the sequence learning problem, where I'm taking a sequence, I can see the sequence from multiple perspectives. One way that I will try to define each and every word of the sequence to a particular class. That is one way. Another way is I may not, I'm just interested in to analyze the whole sequence, and at the end I'm just telling that whether it's a positive, whether it belongs to a certain class or not. Okay. Now, um, now once that is there, that is totally fine. And okay, another point that can are we seeing the sequence only at the particular at the, only in that natural text, or is there any different kind of data is also available? So the sequence type of problem is not only available for text. uh, Sequence learning problem, we can also see it in the speech. Okay, where in the speech I have the whole frequency of the voice, and I am trying to say k, k, g kind of thing, or a, b, c, d. When I am speaking right now, it the model has to analyze that each and every tonation, tone of the word or the character which I am speaking, and then it has to combine to say that which word I am speaking, right? The text to speech is basically doing that part only, right? So whatever I'm sorry, speech to text. So whatever I'm speaking, it can record it. It is analyze my speech, and it will generate into text, right? So that is one kind of sequence learning problem, the speech to text, which you frequently use in your mobile. Okay. So another thing is video. Okay, so we have object detection, video detections and all, right? So video, so we can say that okay, I'm showing the model of a small video, maybe with certain frames. Okay, and I have to classify what this video is all about. So this video captioning is coming to picture. That is another thing which try to analyze each and every frame of the video, which is basically sequence, and based on that it is trying to predict that what is that video is all about, right? And it can't just see one frame and just say that okay, this is about this. It has to see the whole frame, and it has to see the whole input of frames connected to each other to make sense out of it. Okay, so these are another ways of sequence learning problem that we can see. We are mostly looking at right now simple text to for a better understanding, that just to get into motivation that why sequence learning problems are used and why we bring RNN into picture, why RNNs are better for us. Okay, that is what we're trying to build here. Okay, so that being said, so there's something wish list, or we can say some few important characteristics that we are observing from a sequence learning problem. Okay, so the first problem is that, or sequence learning problem, or the function or the model that we are trying to find, we want that this model should cover these three aspects, 3 or 4 aspects here. Okay, so first point is ensure that our y, let's say some y function, our phi model, okay, is dependent on previous inputs. Okay, so this is one model that I am trying to so the model, it should consider the previous input. That is the first point that we are trying to look at. Then we have to ensure that the function can deal with variable number of inputs. Okay, so if I'm giving a text, or maybe I'm giving a para kind of thing, and I'm giving one sentence at a time and all that, the sentence size might be different, right? Some sentence may be 5 words long, some sentence may be 10 words, 20 words long, like that. So if I have different number of inputs with respect to it. And another important point is that, so I have to ensure that the function that I'm trying to build is executed at each time step. So time step, in the sense I will just let you know, is same. Okay, so let's go here again. What do you mean by time step? So what I'm trying to say is, so I have this, it was an awesome movie. This is my 5 word statement, right? So the function that I'm applying here, this is a basically modeling that I'm trying to, this is my y cap is equal to fx, right? Fx hat. So I have some output and I'm giving the input. My model has to learn this particular f dash x, f cap x, right? Now whatever the function I'm applying here, that f dash of x, the same function I'm applying here also. Okay, it should not change. It should not change on its own. Okay, so because my inputs are connected to each other, the so the function that I'm going to apply on that should be same, should not be deferred, because if it is deferred, there's no point of me to bring no point of me to bring uh, the output sequence together, because if I have a same functions for all the input sequence, the same output functions sequence can also, I should get it from during my output, right? If I create f of x for it and was as it's something different else, I might get some different kind of output. I don't want my function should deal that, okay, I have some input, I need to get an output of this 10 of let's say this 5 classes, output classes, and I have to predict like that. So my fx should be same for all these inputs. Okay, so time step, when I'm saying that when you considering one word at a time from the sequence, that is one type, this is time step 1. So at a time, so when I'm considering one instance of the small input, one part of the input, that is time step 1. So this part will be time step 2, this is time step 3, time step 4, etc. Okay, so this is my whole input which is connected to each other, and I'm trying to break this thing one by one. I'm trying to connect them by training my model in such a way that it should connect these previous inputs to my current input. Okay, so when I'm doing step by step, it is doing at certain time duration. So that is a time step 1, 2, 3. Okay, so again come back to this. So what we are trying to say is a model, whatever model we're going to build, should be dependent on previous input, first point. Second point, it can deal with variable number of inputs. Third point, that the function executed for each of the instance of the input should be same, okay, at each time step. Okay, so that is our basically wish list with respect to this. So let's see that how, what can we do with respect to generating towards RNN, right? So what are the other solution we can give, what people have tried, and how we reach to a current RNNs. Okay, so the first basic intuition of RNN is that we will take the same step. So I have certain inputs and I have one hidden layer and one output. Okay, so this is one output, let's assume like this. So I'm just repeating whatever I created here, I'm just trying to create it here. Okay, so um, okay, so this is my input, this is my hidden layer, and this is my output. Okay, and I have some x1, x2, x3, and y1, y2, y3. Okay, if I take the simple architecture that for each instance of my sequence, I'm trying to build a new neural network for that. Okay, now if I able to, when if I'm trying to do this, so I'm getting certain advantages. So what kind of advantages? So the functions that I'm providing here, the hidden layer that I'm trying to train here, it can be same for all these 3 neural networks. How I can do that? With the help of parameter sharing. Let's assume that they can share the parameters in all of this in all these networks. So by some means I can share my parameter learning. So whenever I'm learning better, I'm going to pass this parameter sharing to all of these 3 networks, and I'm trying to learn the my x1, x2, x3 as a sequence. Okay, so if I'm able to do this, my what will help, what it will uh, how it will help me to achieve that, I will have a one function. I'm using only one type of function which is executing at one function executing at one time, each time step. Okay, so my one criteria is almost done. Okay, in a certain way I can take variable number of input as well. So let's say I have only 3 inputs, x1, x2, x3. Let's say I have 25 inputs, so I can build more neural networks, and I can deal with the variability of the inputs. So I can deal with variability of the inputs, variable length of the inputs. Okay, so this is a typical one thing that we are trying to solve at, but it has one major problem, that it is not helping us to solve one thing, that is it is not considering my previous input, right? So this is not happening. So this part is not happening for me. Okay, so what we want to say is that previous inputs are not considered, not considered. Okay, so if you are not able to consider, let's do a different kind of strategy here. Since individual neural networks are not able to do, let's see what else we can do. So what other another intuition that we can do is, let's say I have x1. Okay, so I'm passing my I'm passing my x1, and I'm giving this to hidden layer and output layer. That is one. So I'm doing this, right? Another way what I can do is that this is my input layer. So I'm providing x1 and x2 both in this case. Another, if I want to add more, so to solve that I should consider previous network, what I'm doing, I'm just concatenating my input instances or sequence of inputs to each other. Okay, so I'm trying to give this part to these models. Okay, so that is what I'm trying to do. So earlier my input was x1, then my input vector was become from x1 to x2, then x1, x2, x3. So I'm so each time instances I'm concatenating one input at a time, slowly. Okay, but it has one problem with respect to this also. So what it's doing, it is actually deviating the other 2 points that we have seen here. The first point is that the function that we are creating at each executing step is different. Okay, this is earlier it was same here, but in this case my hidden layer, this is the function that I am trying to build, or let's say the whole output layer that we are trying to build. These are very different it is very different in a sense that these all functions are different. Why it is different? Because if you actually calculate the dimensions, let's say it is r n, the input is of r n dimension, and the it has to go to the hidden layer, let's say of that is for d dimension. Okay, d cross n, and this is n cross 1 kind of thing, such that we can get the output of rd. Okay, so here my input earlier was input of n cross 1 dimension, but if I'm trying to bring multiple inputs here, it will become r to n. So because of that, my input hidden layer will also change accordingly, because I have to accommodate the values for these 2n. Similarly, my input will increase from 2 to 3n, and then based on that my this part will be increased, where I have to consider this d cross into 2n and r d cross into 3n kind of thing. So my inputs, the number of neurons that I am keep on adding with respect to the hidden layer of the function, it just keep on increasing based on my number of input sequence are happening. Okay, so because of this, my network is becoming very big. Okay, the functions are not same at each time step. So at whenever I'm adding new input to my sequence, I have to change my function, which is obviously not feasible. I can't do it all that automatically all the time. Okay, that is one part. Another part is the variability of the length is become exponentially high. So even though I can accommodate to a certain extent, but still my model will become very huge. Okay, so these are the two intuitions. So why we bring this into the picture, to tell you that if you try to bring that, okay, why to create new architecture, let's use the earlier architecture itself to deal with the sequence learning problem. We found that it is not it's not feasible to use the earlier architectures, that is simple fully connected network, basically in this case, to deal with the sequence learning problem, because we have to deal with the these three wish lists that we have defined here. Okay, depending on previous input and output, like that. Okay, so what we are saying is we are now proposing a different architecture, which is a recurrent neural network in this case. Recurrent neural network. Okay, so the intuition is, if I have to take previous input, if I have to take previous into the consideration, I need to have something which can store previous state. Okay, So that is my one of my requirement. Whatever I'm trying to, if I'm trying to create a neural architecture, it should store the previous state somehow. Okay, so that is one important part I want to do. Second important part that we have to deal with it, that upon the storing previous state, my output is also dependent, because my I can store previous state, my output will also be dependent on this previous state as well, because I'm learning a sequence problem, like part of tagging speech, where if I'm saying that movie is a noun, movie will become noun only when I have seen the earlier four letters where it's like it was an awesome movie, right? So to become noun, I have to see that earlier input. So my output now becomes, I can consider my output by looking at my previous state basically. Okay, so in general, if to bring this concept into the picture, what we are bringing is, this is look like a typical RNN. Okay, so let me go through what it look like. So we have this input layer which is shown in yellow, we have this hidden layer shown in blue, and this is output layer shown in green. Okay, so what is happening, there's something called as u right now. This is standard format of uv. Now w that we are seeing in this RNNs are little different from what we see w in the weights, right? uh, so u is basically weights only, but they are giving different kind of abbreviation to it. So from input to hidden layers, if I'm providing, I'm giving that weights as u. Okay, now I'm calculating my parts here in the hidden layer, and output I'm having maybe a classification, something like a something called softmax layer, something like this. So from hidden layer to output layer, I have a weights called v. Okay, now interesting part come here when I use something called as w. So let's look at this part. It was, so we know that it is a var. How we know it's a var? What it is doing actually is, in the hidden layer, sorry, the output layer, what it's trying to do, it is not considering the only the input hidden layer of its own current input, it is also looking at the previous hidden layer as well. So it is taking the output of whatever the hidden layer of previous input, it is taking that. That means if I'm taking the output of previous hidden layer, that means I'm also considering the input of a previous input instance as well. That is, I'm also considering it as well. Okay, so what is in this short, what is happening, that when I'm trying to learn this hidden layer, let me use some other color, like let's say black. Okay, I'm considering the previous hidden layer input, which itself will tell us that we are considering previous input along with the current input that I am using, and based on these two values I'm trying to produce a verb as an output. Okay, so this is the basic architecture, nothing fancy here is happening. What only changes we are doing is, if I'm creating multiple neural networks, I'm just connecting the neural network, one neural network to another neural network based on the hidden layer. Okay, so before computing the adjective layer, this neural network part, I'm considering its own hidden layer plus the previous hidden layer, which previous hidden layer itself is related to the previous hidden layer, like that. So it will come back to the first input as first neural network automatically on its own, right? So it is going from awesome to an, it is considering this, then this third hidden layer is looking at second hidden layer looking at the first hidden layer may be looking at the some zeroth hidden layer. So let's say s0, let's assume that there's some hidden layer is there with certain values. So it is looking at it, and based on that, it is they are computing their own outputs. Okay, so this is the concept of a typical RNN, where I am generate. So how it is helping us to complete a previous wish list. Now it can deal with previous inputs. Okay, I can create this chain of input as multiple layers. So I can have input of variable length. I can keep on adding it without any exponentiality. So I can add it. Now it comes to the function. Now I've said that the function should be same at each time step, right? So the function that we are trying to define here in the blue layer, in this case, it is actually considered as equal. It's actually same. So mathematically, how we can write it as that. So we are writing it as so yi is basically a function of something big of O. It's not big of O, let's of theory, computation theory, just like a big of O as a sum function, V Si plus C. Okay, that this is output of, and Si we can define it as basically sigma can be the sigmoid, or if we can put tan h, anything like that, u of xi is the input, plus w of si minus 1 plus b. Okay, so we have 5 variables here. So let me define one by one each. By this is the output. Okay, xi is the input. Okay, b is the biases, C is the for the final layer, final classification layer. It has the bias of final classification layer. Okay, now we have something called as SI. SI is called as state. Okay, so I am considering my own state plus I am considering the previous states in this case. So if I am looking at the awesome as a input, I am not only considering awesome, I am also considering and was its previous hidden state, that is this blue layer. I am considering them one by one, and to compute my final output by considering not only this awesome hidden layer but also the previous hidden layers. So based on that I can define this, and this u, v and w are basically weights at different context. Okay, u weight is usually for input to hidden layer, v is for hidden to output layer, and w is for between the states, between two hidden layers. Okay, so this is how we have now multiple parameters in terms of RNN, and RNN is typically much more complex to code and all with respect to compared to CNN and all. Okay, so because it has 5 parameters, u, v, w, b, c and xi. Obviously the xi is the input. So this is how our RNN as a theory concept will come into picture. Okay, now I'll just show you just simple example of how RNN just to give intuition that how it can work in a typical system. I'll just give you a few examples, and after that we will take a few minute break, and then we will start the coding part of here. So now I hope you can understand that the sequence learning problem have few things, that it has to consider previous input, first part. It has to previous input, the functions considering at each input sequence should be same, and I can have a input of a variable length. Okay, so all this part can be considered into picture. Now this is something called as this input table. This is X table and this is Y table, and this is for sequence labeling task. Okay, so I'm just saying, let's say it's a review task. So what I'm doing, if I have a sequence, the first half was very boring of a particular movie, a review. So what I'm trying to do here is first half was very boring, and we're defining a certain class to it. So first half was very boring and we're defining 0 class. That means it is a bad review kind of thing. 1 is a good review. The great performance by all the lead actors as a good review. So I'm providing 0 or 1 as a class. Okay, so how I'm doing this, first I'm taking this input as a sequence, as a list, as a particular sequence, and then I'm dividing the each sentence into one individual words. That is, the first half was very boring. So each I have divided into sequence of words. Okay, now once I have done this, you can see that all the statements, or at least few of the statements are of different length. That first statement is of 7 length, some statements are of 8 length, some statements are of 6 length, right? So the first task for me is to make them all the input as of equal length. Okay, so what I can do, I can add something called as SOS, that is start of sequence, end of sequence, and padding. Okay, so if I am able to do that, I can get an input of same size. The reason of inputting of same size is just to give it as a pass of input. Later the RNN will the logic of a framework of PyTorch will automatically see that how big my input sequence would be. Okay, so I will just add this at the start of SOS here, which tell that okay, my sequence is getting started. Okay, and here I will add end-OS, maybe here I will add end-OS, here end-OS, maybe at the 9th part I can add it like that. So I can add few of the end OS, and if I still have a bigger length, so if I have some uh, input length of particular size, I can add a padding here just to make equivalent length. I have to put all the input lengths as the same size to pass it on to my to network. After that, my network automatically will see that from where to where my input sequence is. Based on that, it will try to compute. Okay, so this is one kind of task that we can see right now. Okay, so what we will do is, uh, instead of looking to here, we will look the RNNs from a very basic perspective from the code part. Okay, so uh, then I will just give you outline of what we're going to do with the code, and following which we will take a 5 minutes break, and follow which we will start coding. Okay, uh, if you have any question with respect to RNN, please let me know. I will stop the sharing of this part and will start the code part. Okay, so what we are going to do, I will just give you an outline before starting. So the first part what we're going to see is basically the data set. We are going to define one simple sample data set. Then we are going to uh, see that how to do train test split with respect to this. Uh, so we have a very simple data set that we're going to see. So let me define all the steps, and then we will do basic visualization how our data set look like, so that we can get an understanding that where we are going. Then we will defining the basic network. So first step we will do, where we will just do the inference. So just to know that where our model lies, if I just define a model and I'm not training it, so where our basic classification lies. So it's a basic classification model. Okay, so I have a name and its nationality, so I just need to connect them to each other. Okay, then we will write a evaluate model, followed by we will do the training part for the few batches, and see that how it will work out, and then we will write up our full RNN. Okay, now after RNN, if you want to go ahead, RNN is basic architecture, but based on that you might have heard of LSTMs, GRU kind of things. So that is something we are not going to cover as of now, because by the time it will reach, it will always time will be over. So but we will see the basic this first 7 parts. Okay, so we will see this right now. So what we will do is, it's already 6:53, maybe by 7 o'clock we can come, and we will then start the basic coding part of this. Okay, so let me stop sharing as of now, and if you have any questions, please type down in the chat section, or you can unmute yourself to speak with me. Otherwise we can take a break now till 7. From 7 we will start. Thank you. Okay. Okay, uh, welcome back. Maybe I'll start now with respect to the coding thing. Let me share this collab notebook. Okay, I've shared that in the chat box. So let's start. Let me import few of the things from the some basic functionalities. So I'm putting some basic Python libraries because we are going to deal with the text data. So just adding few stuff, basic libraries with respect to it. So matplotlib for plotting plus import cbon as sns, import numpy as np, then from sklearn model.select underscore selection import test training, train test split, and we're going to import torch library, PyTorch library to create an RNN network. For this we have to write torch.nn, we are defining as nn. Then for bring the optimizer, so we'll use torch.optim as optim, and I think that is more than enough right now. So let's run this part. Now the first part is data set. So let me write it as data set. So what we are dealing with here, so let me show you. So this, okay, are you able to see my screen? No. Okay, I'm so sorry. Okay, I think it's coming now. So we have defined few of the uh, basic libraries that we are going to use in this code. Okay, now dataset is basically is like this. Let me see, can I zoom in? Okay, so it is basically a name and the language the person speaks. So there's a person name and the language it speaks. So we have Portuguese, Irish, something like that, right? So what our basically task is, if I give a name, I have to define that whether that name of the person belong to which of the languages. Okay, so that is my task which I'm going to do using the RNN part. Okay, so this is my task that I'm going to do. So this is come as a name blank text. So I have already have a file, I will share that with you later, that is name2lang.txt, where I have this data with name, comma, and I have the which language the person speaks. Okay, to do that I am define. So now what I'm going to do, I'm going to do some pre-processing where I'm going to divide the languages and the name which I'm telling as data. Okay, I'm going to have input as x, y, sorry, small y as output. Okay, so with open name2lang.txt, I'm taking as a reading format as f. For line nf, line is equal to line.split. So what I'm going to do is I'm going to take each and every line, and from that line I'm going to first I'm splitting it, and then I'm extracting the names and the languages. So I'm extracting the name, then line equal to 0. So I'm stripping based on the argument called comma. We have comma in the each line, so we are doing this. So line dot one dot strip. Um, so once am I able to do this, then I'm going to append all the languages, and so I'm saying if lang is not present in languages, which is our list, we just add languages dot append dot lang. Okay, Now once able to do this, then we are going to append names. So mostly all names are different, so we don't have problem with that. And y dot append lang. Okay, so we are keeping both input output. So y considered languages, and language also contain the same. And data consists of data dot append. It has two variables, that is name and lang. So these two part is there. And finally, and languages will tell us length of how many languages do I have. Okay, so let's run this part as well. Then to show that how many languages do we have, let's print languages. So we have multiple languages like Portuguese, Irish, Spanish, Vietnamese, French, German, Scott, English, Russian, Polish, Arabic, and all that. Okay, so let's run that top 10 data. So we are right now not using pandas, we are just doing a simple random list operation. So we are seeing that the first names are basically the names of a person and the language they speak, right? So that is there with respect to this. And okay, so once we have seen the data how it look like, that it has the name of the person, the X as a X, and the Y as a language is Portuguese, Spanish, French, and all. Let's do something called a train testing part. So what basically we want to do is, before training the part, we first want to inference it. Okay, inferencing, we just want to see that if I don't apply the model, how it will work like. Okay, so to do that, let's divide the X train test data. So we can divide the so this another important factor here, that you can divide your train data. Earlier we had divided the data based on the numerical factors, right? So based on number of instances and all, we earlier only see the in the numerical instance, not as a strings and all. We can do the same thing here as well. There's no problem with respect to it. So even if your data is consist of strings, you don't have to convert to any other format before applying the test training. You can do that randomly like this as well. So test size is equal to 2, that means 20% we are giving the test size. Random state is equal to 0. For reproducibility, the basically we are doing this, and the stratify. So how we are going to divide the data, it is based on the our y is a class that we are having. And if we print X train, so now we can see that now, because we are, it's some random shuffling is happening, we are looking at the X train data with randomly assigned. Okay, so to see that how many number of training and testing data is there, so we can write len of X train and len of X test. Okay, so so based on that, we can see that we have almost 16,000 as a length for the training and the 4,000 for testing. That is almost 20,000 data points we have, which 80% has been given to train and 20% has given for testing. Okay, now let's start with some encoding part. So we have discussed earlier in the theory session that we can use one hot encoding. So we're going to now encode names and languages from our data set. Okay, to do that, first we are defining all letters as, so we define the number of letters. So string.ascii letters will give the number of letters, that is small a to z and capital A to z, followed which we are also adding something called as dot, comma, and the semicolon, just for the basic understanding. If we have data set which contain more than this, we can add them. Okay, so all this thing we are defining manually right now for understanding. And the length of all letters. Okay, so we can print also. What is the print of n letters? Okay, so we are creating each encoding of 56 a vector of 56 values, where along with so we are taking names right now. So what it will happen is, so what I will do is, let's say Dubin, right, or Duncan. Duncan is an Irish word. So how I'm going to create my RNN is, I will take D at a time, then I will take U, then N, C, A, N. So I will divide this Duncan into 6 characters, and then based on that I will try to join them and try to output that whether it is the person speak which language. Okay, so that is my this is how my RNN should work. So that's why when we are doing one hot encoding in this part, so we are creating a vector of 56 values, and whenever those letters are there, Duncan, so capital D will, we will see that how it will look like. But the we are saying now, we are defining that one hot encoding should consist of small letters as well as capital letters, along with the commas and dot and all those stuff. Okay, now what we're going to do right now is we are going to define certain functions to present that names and the languages. Okay, so to do that, we pass the name as an input, and to do this we are defining torch dot zeros with length of name 1. We will discuss later what is actually look like, and then letters, then for index letter in enumerate name. So what I'm going to do now, I'm going to take each letter from the name. I will provide a certain position to it with the help of index. So position will be all letters dot find letter. So I've given a name, I will divide that into each character, and then I will find the position of that letter in the all letters index. So I have a this vector of 56, so from that I'm going to find the position, and once I'm get that, so I'm providing the name. So I will say index, at what index, so I'm going to iterate with all the names that I'm having. So index with position of 0 and position. Once I'm able to do this, and I will assign the one value, and then I will just return the rep. Rep be basically the representation of that particular word or particular name. Okay, we will see that how it will work. So this is for the name, and for language, what we are doing instead of dividing them into single words, we just define them as a particular class. So we just write as torch.tensor languages dot index dot lang, okay, and d type torch long. So for like we will just give Portuguese equal to 1, Irish equal to 2, like that, using this code. Okay, now to see that how it will look like, I will just say call this function name rep, and I will pass on this value abrew. Okay, this is one of the names from the data set. So if I do this, now you can see that this, it has created 5 vectors. Okay, one belong to each of the character. So A belongs to this one, abrew belongs to A, this highlighted one belong to B, third vector is belong to, sorry, I'm highlighting now, third vector belong to R, fourth vector belong to E, same like that. Okay, now if you can see, it's a one hot encoding. So what we are doing is, so A is a capital A, so after 26th letter, 27th letter will we have A. Okay, now B is here small b, so that's why the one we are getting here 1, and rest of them as 0. So this is the concept of one hot encoding. So this is one pretty simple way to define a character into a set of a particular array or particular vectors. Okay, so this is one way. And to see that language, how language has been represented, so defining as a class, so if I just write Portuguese, if I run, sorry, I think this word is not existed. If I run this, so I'm getting a tensor of 0. So I'm just defining the class number here, nothing more than that. If I put Irish, I'm getting as tensor 1. Okay, so now we have converted our input data and output data to a particular numbers. Now we can deal with these numbers. So before that, just see that how our data actually distributed in our data set. Okay, so let's do the basic visualization part. So what we're going to do, we're just going to count how many Portuguese, how many Irish people with name we have. So to do that, we'll define a count variable as a dictionary. So for L in languages, we just count L equal to 0, and for D in data, we're going to write count D of 1. So for each D of L, basically the D of 1, we just go add plus 1. Okay, so for each, so what we are doing from data, we are finding the languages, and for each count level we are finding which data belong to which of the languages. Okay, now if we run this and we do print of count, so we can find out for each language how many number of names we are associated with it. So Portuguese has 74, Irish has 232, Spanish, Vietnamese, different numbers, right? So let's plot it to in a bar graphs to see that how it look like. So let me use it as an bar plot for this, and x is equal to list of count dot keys, y is equal to list of count dot values, and plt underscore dot set underscore x tick labels. So I'm just writing the code to how to print this whole value, so just bear with me for a few minutes. X tick labels and rotation equal to 90. I just put, and then I will just do plt dot show. Okay, so now we can see a bar plot here, where we can see that for 20,000 data points that we are having, how many number of names are belong to which number, how many names belong to which of the languages they speak of, right? So Russian, we have Russian, English as the highest and second highest respectively, followed by other languages, right? Now what we are going to do, now once we know that okay, this is how our data look like, now what we do, we would try to infer it. So the reason of having an inference, basic inference or testing is, now we know that that we have one particular category that is called Russian, which is typically is way more, or maybe the half of the points are actually related to Russian speaking, and rest of them have very less number of value, right? So ideally the basic classifier will give us 0.5, but in this case maybe the most of the points might be related to Russian, right? We don't want that, so we just want to see infer. So if we don't train our model, how a model will act like. Okay, so for that is something very much necessary before the training, to see that how our data has been skewed and what can be done to deal with the skewness of the data. Okay, so what we'll do, we will basically bring basic network. We'll define a basic network and we'll do some testing inference on top of that. Okay, so let's start with it. So to do that, we will define a class called RNN. So RNN network, and which we can call it from nn dot module, and we're going to define init function. So if you have attended earlier coding sessions, we always define an init function and forward function when we are trying to define a particular network architecture. Okay, so along with the self, we are passing few values like hidden size and output size, like this, and we're going to call super RNN net, and we're going to call the self variable here again dot init. Okay, so this will call the super class of this NN module and try to initiate the RNN network, and then we are defining the hidden size here for hidden layer, which should be same for everyone, for each of the neural network that we are defining. Then what we are doing is, so from input to hidden layer, we're defining one layer. So how we can do that? We have to write nn.linear, and we'll put input. So it's a combination of input size as well as the hidden size. Hidden size, that is the previous input hidden size also we are considering. So we have to add the dimensions here. So we'll write input size plus hidden size followed by hidden size of that particular layer. So this is the neurons we are trying to define. This is for input to hidden layer, and then we will have as input to input to output. So we will define as nn.linear, same input size plus hidden size by output size. See, what we are trying to do here is, our input has been associated with not only our current input, we are also with the hidden layers, not even our current hidden layer but also previous hidden layers. For that we are defining these two lines here. Okay, and then the final output layer will be basically a softmax layer. So we are defining it here, nn.log softmax with dimension 1, because we are just defining one particular class out of. Okay, so that is done for our, we have defined the RNN architecture just like that right now, and then we are going to create a forward function which is do the forward passing, feed forward part. So here we define the self input and the hidden size. Okay, and here the actual thing we are trying to do as a computation, where we are concatenating using toss.cat the input as well as the hidden layer, and we're passing this value, and then hidden layer we are taking from self dot I2H combine, and then output is self dot I2O combine. Okay, now once the output is done, self dot softmax layer will apply here output, and then we just return the not only the output but also the hidden layer, because this hidden layer we're going to pass it out as a input to the next hidden layer. Okay, so this is defined, and then we have to define another function called init function, init hidden. So we're initializing the first hidden layer before the first taking as an input. So to do that, we just write return toss dot zeros 1 comma self dot hidden size. Okay, so this is what now we have defined the typical RNN network here, and let's define some hidden. So what is the number of hidden networks neurons we have? We want is 128, and we instantiate this whole class using the net variable, and we're going to pass RNNet class with the inputs of number of letters that we are having, number of hidden neurons that we want, and the number of languages we are having as an output, right? So input size, output size, the hidden size we are trying to give it here. Now once we did here, now we will write an inference function here. So let me write it quickly. Def infer, we pass the network here, and then we pass the name as output. We'll put our network as an eval mode, not as a training mode. So once we put in eval mode, the PyTorch will understand that it has to, the name will be used for testing, not for training. Okay, so we'll just do, then using the name that we're giving as input, we'll create a one hot encoding vector, and we'll put that in name underscore OHE, and we are going to pass hidden, which we are initializing it with init net dot init hidden function, and we are going to pass nothing here. Okay, so once that is done, so for I in range name dot name underscore OHE dot size 0, so it will take the whole vector and go one by one, and it will pass the value of then we will call the then we will call the this network and pass one value at a time. And just a minute. Yeah. So okay, so what we are doing is we are taking now one hot encoder vector, and one by one we are going to pass this one hot encoder. So when we are saying one hot encoder vector, so I want to say this whole tensor that we are seeing, right? The one hot encoder for 5 characters one by one. Each character we are trying to pass it on. So that is what we are trying to pass, and we're passing the number that we are going to pass the initial hidden weights. We're going to pass that, and from that we'll get the output of that particular output from the particular character, also as the hidden layer weights. So once we get these values, we're going to return the output. Okay, so now what to do this inference part, we will do infer. We just call infer function. We'll pass the network and we'll pass some input name that is called as Adam. Okay, now index will whatever the output we are getting, from that we are trying to find for to which category it is belong to. So output, what we are getting as output here, we are going to pass that with toss dot because it will bring is a set of classes, so it will give certain probability to each class. From that class we are trying to find the maximum value. So once we find that value, we just print the output to index. Okay, somewhere I have done wrong. This I have written soft max into a soft max. Okay, my bad. So let me write it here again. Okay, so if I give as Adam as a name, as an input, I'm getting certain values here, and I found that this Adam word is belong to the class 9, tensor class 9, which has this the lowest, which is the highest value among this. So out of 26, out of the 20 variables or 2022 different class languages, I'm getting Adam belongs to the particular 9th class. Okay, so this is what inferring we are doing. So but let's see as a overall accuracy. So since it's a kind of classification problem, we are trying to give as an input, and we're just trying to find that the name belong to which of the languages. Okay, so we have to evaluate it using the accuracy. So let's write a simple code for that. So what we're going to do, we are going to evaluate our model. Okay, so we're going to find def data loader. So evaluation endpoints, we will see what is this endpoints, and x and y are the basically input output to return. Okay, so for I in range endpoints, then we are going to have index underscore equal to np dot random dot randint len x underscore. Okay, so what we are doing is we are giving some random index to this point, and we are going to find the name and language. If we pass this index to it, x underscore index and y index, sorry, I just put that into a square brackets. Okay, so once I might do this to get dot append, so I have to pass this name, lang name, name rep, name, lang rep, lang. Okay, I'm passing many of this value, but let me do this once. Let me write, and then I will explain this properly. So what we are trying to pass and what we're going to return. Okay, so once we have this and data loader to xtrain ytrain. Okay, so what we are trying to do is to evaluate the model, we are passing the xtrain value and the ytrain value. Okay, and we are passing the number of data points. So, number of data points here, maybe 2 names here. Okay, so once we give this to data loader, we will create an iterator in this case, and it will assign certain randomly index to this each data point. Okay, so once this point has been done, then what we're going to do for each name and the language that we're providing for each data point, we are going to have a one hardcore encoder, right? And then it will give this whole list to me as an output. So once I'm able to get this, let's see how it will look like. So if I'm giving like name as randomly taken name as Makhenko from the data set, and it is a Russian, right? So this whole Makhenko, maybe it is consist of 4 plus 4, 9 birds, right? So it has 9 into 56 data set tensors for this, and this is how my train loaders look like. Okay, so data loader is basically I'm loading my data for each name and language and creating its tensor for both the name and languages. Okay, so once I'm able to get this part, now what I have to do is I have to define the evaluation part. So now I have created data loader which can, if I pass only random 2 points and from the training and testing data, then I can create my own name representation. Okay, so once I'm able to do that, so net I will point number of points, my network number of points, k is belong for top k outputs from the top k output means in which name that belong to which of the categories, and passing input and output. Okay, so for this, sorry, yeah, so I'm going to pass the data as data loader, passing the endpoints here and passing the input and output. Then we're going to write correct equal to 0, which going to see that which data points have been correctly classified. So for name language, it's one hot encoder of name and language representative language class from the data. What I will do, output equal to infer, so I will just call this infer for providing the network and the name. Once I am able to get that, then val indices, I'll get in the also output, and then I will check the output from the top k values. So top k accuracy, if I have already have known that if I given a name, I will get a list of probability for each of the classes, and from that if I want that, I would just want to see the probability of first two or first 5 class which have a high probabilities. I will look at that, and from that this first 5 probability first 5 classes, I will check that whether it is predicting the correct language for my particular name. So that is what I'm trying to do here. So if then I'm going to have then I'm calling the if lang rep is present in any of these indices as an output. So I will say that yes, my model is correctly inferring, otherwise it is not inferring. Okay, so I'm accuracy I'm doing correct divided by number of points, and then I'm returning the accuracy. So this is a simple part I am doing, and then let's do this evaluation. So I'm passing the network, then passing the number of data points I want to have. I want to see the output from the um, top three accurate highest probability classes, and then providing X test and Y test data. So if I do this, so I'm getting that I'm getting the accuracy of 0. That means for none of the value it is able to predict the correct class. For none of the names is predict to correct language, right? So now we can see that a basic inference model is not working. So what we can do is let's start the basic training part, and let's build the RNN for that. Okay, so before even building the basic RNN, what we can do is let's train the basic for a particular batch size. We will just train for that, and then follow which we can do a full training code. So if I'm running this, so I'm just defining a train as a class, train as a function where I'm passing the network, I'm passing the optimizer, criterion is my network, loss function, and endpoints is my number of data points I'm trying to pass. Then optimizer dot zero grad, that means I'm for gradients I'm just initializing all the gradients at 0. Okay, I'm calculating the total loss as well, so I'm just putting as 0 right now. I'm initializing this part, and then from the data, using the data loader function that we have created earlier, I'm going to pass this data and number of points. I'm going to pass the X train and Y train data because we're doing the training part. Now for each name, language, it's one hot encoder and the language rep in data. Okay, hidden is equal to net dot init initialization. I'm initializing the first hidden layer, okay, randomly, and then what I'm going to do for each one size hot encoder, so I'm going to take each name one at a time. So each name, each letter one at a time, I'm going to take that. So I'm going to take one hot encoder of that part, size of 0. So output, so yeah, sorry, output is output and hidden equal to, so when I'm passing this output and hidden, so I'm passing that to a network, my network with one hot encoder of that particular character, and then I'm passing the hidden layer value. Okay, once I'm getting the output of that particular neural network and plus the hidden layer value. So once I'm getting that, I'm sorry, I haven't written the whole code. So what I'm doing now, I'm calculating the loss after each of the um, iteration of a particular name. So how to do that? I'm passing the criterion and then I'm passing the output and the language rep. So it's just checking whether the output and the language rep of the original name is correct or not. If based on that, it will now do the back propagation. And if we do retain graph equal to 2, it will look at the previous all instances of the hidden layer. Okay, and then total loss, I'm just going to calculate total loss from the each name. So once I'm able to do that, I will do operator step, that is I will update the gradients. Okay, so once I'm able to do that, then I'm just to do return total loss divided by endpoints. This is my basic training point. Now criterion is basically I'm using in this case for RNN is NNL loss. So this is it is kind of cross entropy. It's a little different from cross entropy with the same concept. It is called as negative log likelihood. Okay, so once I'm able to do that, I'm creating the optimizer now. So optim.sdg SGD, that is stochastic gradient descent, where I'm passing the net parameters, all the parameters that I have learned as of now. Then LR is equal to 0.01, that's my learning rate, and momentum is equal to 0.9. Okay, so for this stochastic gradient descent, I'm passing these parameters, and I'll just calculate the how much time will it take to run this. So if I run this for train, that is I'm providing network, providing my optimizer, providing my criterion, that is the loss function, and the 200 and the number of data points, right? So for 200 data points we are going to learn it, and let's see how much output it will give. So net, so for to use that, I'm passing the eval function that we have done for evaluation, and we are checking for only top one result. So we are going to from the list of output, we are just seeing the which is how much it is predicting the best way. It is giving 0. I think something is wrong here. Let me go up and then reinitialize the whole this thing. So I think that will be much better. So I can do, so if something is wrong with my data set, what I can do, I will just go rerun all the before cells. So I can do runtime and run before. So if I run this part, and okay, I think I missed some part here, because eval is here, it's coming 0.01. Here it's not coming, so somewhere I am getting wrong. Okay, let me check that part later. Let me first give you the full training setup now. Based on that, then we can see how it will work. Okay, only the two lines of code, two functions are remaining. So let me write that part as well. So I will just provide the full training setup, and then we will see where the problem actually lies. Because logic wise it is correct. I think somewhere the input is not getting properly. Okay, let me do that. So the full training thing, I will just copy this whole part from train and just defining a train. So I'll just give a train setup here. Okay, so I have net, then I will pass learning rate as 0.01, and batches, some and batches I'm providing, it will learn for 100 batches. Batch size, so I will take 10 batches, and say number of batches is 100 with each batch size of 10, and momentum is equal to 0.9 for stochastic gradient descent, and then display frequency. Okay, so this display frequency is mostly for plotting our output. We will see that how to do that as well. So once we are able to do this part, then let's define few stuff. So criterion dot equal to nn dot, so we're defining the loss function now, nn loss. So once that is done, opt is equal to optim dot sgd net dot parameters, lr equal learning rate is equal to lr, that is we are defining here, and momentum equal to momentum. So this is for the optimizer that we are building right now. So once we define this part as well, okay, so let's define loss now. Loss equal to loss of array, so np dot 0. So I'm going to find loss with respect to each batch. Okay, so I have 100 batches, so with respect to each batches I'm going to find. Okay, so that is part is done. Then I think, okay, I think I need to change this whole part. I will just delete this, maybe it's not going to work. So what we can do for I in range of each batch, so for it's going to run for 100 times, and I'm going to calculate the loss directly. Okay, so how to do that? So loss of ARR of I into I plus the train function that we have defined earlier. We are going to pass the network optimizer criterion, that is the loss function, and the batch size, and then this part is done. Okay, then okay, divide by I plus 1. Okay, so what we are going to do, for each batch size we are going to calculate the loss, and we are going to pass this network to we're going to pass this network. Oh, sorry, what happened? Yeah, sorry for that. So we're going to pass the whole network optimizer criterion with batch size, and we'll get some output of loss, and we're going to calculate the loss for each batches and going to divide by, because we are taking the average of it, so we're going to do that. Now once we're calculating loss, we're going to display it. So if I underscore I display frequency is equal to display frequency, -1. So I'm going to display for after every 5 times. So for that I'm writing this code. Okay, so once I do this, display frequency that we are defining here. Now what we have to do, we have to clear output. Okay, so I have to define one more function here, one more parameter here. So okay, so let me write the code for the how to show the output after every iteration. So I'm just trying to do that. Screen share has been stopped. Okay, sorry for that. Okay, I think now you can see. So iteration, for each iteration we are providing 2 losses, that is top 1, and for that we'll do top net, we will pass net and len of x test top 1 accuracy and x test and y test. Okay, that is one part, and let me copy this whole again. Then the same thing we're going to do for top 2, eval net len text. Here I just need to make it 2 x test y test, and then I will have to write loss of each iteration. Okay, so if I do this part and then I will do plot.figure, some wrong input is there. Okay, just a minute, let's just do this part. And okay, I think now it works. I hope so. Let's see. I think some issue with respect to the arrays is there. Let me plot that also. So let me write the full code. So I'm going to plot for loss after after 5 iteration. So I'm going to plot that, and also having the number of instances I'm going to see after each batches. So plt.xlabel iteration plt.ylabel loss plt.show and print /n/n. Okay, so let me first check where I'm getting wrong in the print part. So I have top 1. Okay, top 1 should come like this, and we have eval net and top 2. Okay, like this, eval net x test y test, and this, I think now it will work. We still have some problem with clear output and display frequency. Okay, so for clear output, what I have to add one more code here. I have to import one more function. So I'll just let me add that from ipython dot display import clear output. Run this part and display frequency. Okay, so I have some red points here. Let me see what is the problem. If I modulus of display frequency is equal to display underscore frequency, display frequency of same name is equal to display frequency -1. Yeah, I think it should work out. Let's see what is the problem with this. invalid syntax I am getting. Oh, I need to add as not for as if. I think this should work. Yeah. So okay, so we have defined this full batch training set, and then I'm going to pass the n number of hiddens, that is 128 hidden neurons. I'm going to pass the create the network, which I can say rnn.net, and here I'm going to pass the number of letters, number of hidden neurons, the number of languages. This is the final step we are going to do. We are almost done, and then we have to do train setup function. We call train setup function, and net learning rate is equal to 0.005. Let's assume some learning rate. Batch sizes of batches of 100 and batch size of 256. So each batch will consist of 256, and we have 100 batches. Okay, so if we run this now, so we have written certain output for that. Now we will see that. So here we are going to get this output. So after 5 iteration, it is showing us. So after 5 iteration, it is showing that how our loss will be decreasing. Now we have certain problem with the top 1 and top 2 value. I need to check the code. I will check it back right now where the problem is. I will show the updated one, but you can see that how the loss is changing with respect to when the iteration has been increased. Now this points of stars is basically one batch at a time. Okay, so this is how it will run. So it will run for some time. So let me recap of what we have done as of now till now. To summarize this part, so we have seen this something called a sequence learning problem. In sequence learning problem, we have multiple types of sequence learning problem, and to solve that, we have certain constraint that we should take previous input as during consideration, and followed by we should also consider that we should have a similar function when we are going to consider for new inputs like that, right? And the input has a different kind of variability. To do that, we have defined the RNNs. So here what we have done in this code, we have taken a data set. Now data set look like this, where we have a name and we have associated language associated with it. Okay, so we have this this part in towards it. Now what we're going to do, we are presenting this names and languages with one hot encoder, and then we are defining something called simple RNN architecture. So let me define here. Let's go RNN architecture where it is there. Here. Okay, so we have something RNN architecture. So here the importance given to the, let's say to give, I'm highlighting right now from input to hidden and the input to output, where we are considering not only input and output, but also we are also considering the hidden state of the previous input as well. So when we are writing self I2H and I2O, it is considering the previous hidden state as well, and based on that it is calculating the particular hidden size and output size for this. Okay, so we have 4 layers. One is hidden size, that is to define the number of hidden layer neurons for that. Then we have 2 linear layers, where we take input as well as hidden size of the previous output, which computers to give the hidden size of the current input. Okay, and from the current input and input size, we are going to calculate the output of the current input. Okay, so that is what we are defining through RNNs and all that. In the next lecture, what we're going to do, this is still everything has been manually hand coded and all that. What we're going to do, we are going to define a proper LSTM, and then we will end with the typical transformers with encoders and decoders. So these two concepts are remaining. So once you're able to do see this part, then we have seen we will see 4 different type of architectures. So one is the fully connected network, the second is CNN, this is third part, that is RNN, and the fourth one is transformers, right? So these 4 architecture you will be learning through this course. Okay, so this is part, and I think the iteration has been stopped. So loss is pretty low, that is 0.07, but we have seen that there's something wrong with the code where it is not taking the top 1 and top 2 accuracy. I will check the code and I'll update the updated version of the code. Okay, so if you have any question, please let me know. So otherwise the session is end from my side. So let me stop sharing this part and let me see if there's anything in the chat box. Okay. So right now you have seen this is a third type of neural network architecture, and if you see conceptually it is not that different from fully connected CNN. It's just having just one more connection where it is also considering the hidden state of the previous layers. Okay, so that's the beauty of the RNNs. Now the fourth part will come as encoder decoder, which is not that much different from these three architectures also. Only the attention mechanism will come into picture. Okay. But if you have any other questions apart from this, please let me know in the chat box, or you can speak out here. Okay, so if you want to discuss, putting out my chat email ID. Okay, so you can just mail me here, and if if not able to understand any part of the course or any other aspect, just let me know. Okay, in case if there's no other question, then I will stop the recording and collab link if you want to have. Okay, let me stop the recording first.